Hi, welcome back. So now what we need to do is to clarify certain terms. You will often hear terms like AI, machine learning, and deep learning used synonymously, as if they are the same thing. Well, let's take a little more look into these definitions. It's really important that you clarify this. In general, we stated earlier that artificial intelligence is the field of computer science that enables IT systems to perform those tasks that normally would require human or natural intelligence. However, AI cannot really happen without machine learning having been done in the background. So machine learning is a subset of AI. And as we'll find out, machine learning is always what is at the heart of artificial intelligence. So to a certain extent, these can almost be thought of as being one and the same. In fact, as a recruiter in this field, you'll begin to realize that very often the term artificial intelligence may not even come up in that job spec. The skills they'll be asking for will be machine learning skills, because that is the engine behind artificial intelligence for the time being. So it's essential that you understand this area in detail. So how did it all start? Now remember, I'm making a distinction now between artificial intelligence and machine learning. And it's widely acknowledged that machine learning itself was used for the first time in a formal sense by Arthur Samuels at IBM in 1959. He'd created a machine that could play drafts or checkers, as is known to you people in the new world. And he had written a journal outlining his methods with the catchy title, Some Studies in Machine Learning Using the Game of Checkers. So he was exploring this idea of whether machine learning could endow artificial intelligence. Surprisingly, Samuels did refer to the new discipline as one that, importantly, gives computers the ability to learn without being explicitly programmed. Now that's a beautiful definition. It's something you need to be cognizant of. It really is a visionary way of defining the topic of machine learning and AI. The idea that machines are somehow self-teaching in this sphere of computing is really at the heart of the whole concept, and it's something that you will need to get a grip with. Computers that are given the ability to learn without the need for further programming, well, that's interesting, but that really is at the core of artificial intelligence. Let's get deeper into this area of machine learning. Machine learning is the branch of computer science where humans teach computers how to study and analyze lots of raw data. That's a simple definition. And then using this data, they will learn to make decisions and even automatically continue to teach themselves without further human intervention other inferences about that data. So in this way, people from various industries can hope to utilize all those vast reserves of data around the world that are currently being generated by you and me. And they can exploit the potent untapped resources residing within those pools of data. There's a reason why big data is such a huge topic today across the whole IT spectrum. Because the underlying patterns and trends within big data form the basis for machine learning. Machine learning allows many industry sectors to carry out data mining, data analysis, and many other techniques on raw data to make much more sense of it. Using various data analysis tools, they can tease out and understand what the real story is, the real true narrative beneath the data. In other words, what the data is trying to tell us. In fact, using the skills of data scientists, as we'll see in the Big Data Masterclass, they can not only see what is the state of affairs at the moment, but more spookily, they can also project into the future things about you and me, and see what the future holds for all of us. This is a process known as predictive analytics. This thorough knowledge of the data at such a granular level, if you can program that into a machine rather than humans doing it, if a machine can understand the trends and patterns in the same way that a human knows how to, well, that behavior is known as machine learning. If the patterns and behaviors you teach it, for example, relates strictly to the shapes of trees, the buildings, roads, the movement of cars and children running across the road, then probably the machine you've just trained up is called an autonomous vehicle. On the other hand, if the patterns you teach it are more to do with the shape and color of eyes, the configuration of mouth to nose in relation to chin and forehead, then possibly the machine that is undergoing training is an iPhone X face recognition system. So you can understand that machine learning sets up IT systems to exhibit behaviors of intelligence in their narrow field of intelligence, or sometimes in a broader sense. It also makes sense that in general, the rule is the greater the data set you have at your disposal, the greater will be the accuracy of your results. Kind of makes sense. Your conclusions and the quality of your machine learning will definitely improve with the amount of data you feed into that machine. If you only ever showed a face recognition system 2 pictures of humans in its entire training course, then pretty much any face with 2 eyes and a nose would pass security. Now, the more data you give it in terms of what faces look like will enable it to actually differentiate one person from another. So machine learning is best when it's allowed to tap into vast, diverse sources of data from ideally multiple sources. These could be data generated from IoT devices, social media, search engine results, even online transactions from global websites like Amazon. In other words, machine learning and the big data fields go hand in hand. It's really important for you to understand that you will see many of the same skills and qualities turning up on the CVs. So many of the terms I refer to in this masterclass will overlap with the areas of data analysis, data science, and predictive analytics. There is a tremendous overlap, as you can see, between what the machine learning engineer does in AI circles and the role of the data analyst and data scientist. So now that you've grasped the fundamentals of machine learning and how it teaches machines, let's look at how we collect this raw data and make sense of it. The way humans teach the machines how to study the data is through the use of algorithms. We are going to get seriously down and dirty with algorithms in a following episode, but first let's take a look at a simple definition of algorithms right here. An algorithm, and you're going to see this term a lot in AI circles, in machine learning circles. An algorithm, as we'll see in much more detail later, is a set of rules and procedures that allow you to solve maths problems. And when applied to large amounts of data, an algorithm gives you, through the maths, the ability to structure the apparent chaos within the data. So lots of data, seemingly random, you apply an algorithm to it and suddenly it makes a bit more sense. An algorithm can often be described in terms of, if you do this, then there is a huge likelihood that this will happen. So do this. You think in algorithms all the time, actually. We as humans think in algorithms all the time, especially when we're forced to make key decisions in our life. You'll have done it. Let me for a minute pass you over to the nearest we currently have to an AI-human hybrid system, albeit fictional, describing how an algorithm might work.